Here's how you could code faster in Python using LangChain. Now, thanks to an AI app I built using LangChain, I was able to more than double my coding efficiency, and you can too. Now, with this AI app, you can turn ideas into Python projects, speeding up your development without complex or repetitive coding. Stay tuned as I reveal how you could harness this AI app to increase your coding productivity. This video is brought to you by SciModel.dev, but more on that later. Now, this AI app is called PyGenX, which stands for Python Generator and Executor. Its main job is to transform developer LLM prompts into functional Python objects. Doing this, your coding productivity is increased using a no-code approach for basically any programming task. But now you're probably asking, why do we need to use PyGenX over systems like ChatGPT that is already helping programmers doing their coding tasks? Now, there's a compelling reason for that, but I will discuss it later on in the video. But for now, let's see PyGenX in action. Now, in the first developer prompt example, we are asking to solve x in the following equation: x squared plus 5x plus 6 equals 0. Print and explain your results. Now, the way PyGenX handles this prompt is through the AutoHandle function. This function not only creates a code for the task and execute it, but also does error handling in case of error messages, since of course LLMs are still not perfect. Now, the AutoHandle function returns 3 items: the code that resolves the prompt, its explanation, and error messages if any. Now, let's run the example to see the output. Now, as you can see in the output of the code, it says the solutions are -3 plus 0j and -2 plus 0j, which is the solution for x in the equation. Now, although the solutions are printed in the output, they are Python objects saved in the variables sol1 and sol2, so you can print them, for example. Now, as you can see, we were able to transform a developer prompt into Python objects just by prompting the LLM. With PyGenX, you can also perform data cleaning and data analysis with zero code. Now, in this code cell, I'm importing the Titanic dataset from the Seaborn library and assigning it to the variable Titanic data. Also, I'm defining each column in the dataset in the variable description. Now, PyGenX also allows you to chat with your dataset by prompting, for example, get the sum of fares in the Titanic dataset, print and explain your result. As you can see in the output of the code, it says the total fare in the Titanic dataset is 28,693.9493. Now, the total fare value is already saved in the total fare variable, so we can access it as a Python object. Now, as another example, we can ask, what is the number of male passengers in the ship? Print and explain your results. As you can see in the output of the code, it says the number of male passengers are 577. And this value is already saved in the male passengers variable. Now, as you can see from both examples, we are able to chat with our dataset just by prompting the LLM. Now, in this code cell, we are performing a set of data cleaning procedure on the Titanic dataset. First, we are asking to drop the who column. Secondly, we are deleting the rows where the survived column has missing values. Third, we are imputing the missing age values based on the median age of passengers within the same P class and sex group. Lastly, we are asking the LLM to scale the features like age and fare using a standard scaler or min-max normalization. Now, PyGenX adjusted the Titanic dataset and assigned it back to itself over here. Now, for example, you can print the Titanic data to see its new values. Now, PyGenX does not only allow you to chat with your dataset and perform other coding tasks, but also does error handling as well. Now, in this coding task, we are prompting PyGenX to get the sum of fares in the Titanic dataset and make intentional mistake in the code for testing by naming the fare column as capitalized fares, print and explain your result. As you can see in the output of the code, it says error message after executing the generated code. Here is the error message, fares. So PyGenX was able to detect that fares column, the capitalized version of the word, does not exist as a column in the dataset. Now, after this error detection, PyGenX says this is the first of 3 tries to fix the erroneous code. Then it gives the correct value. Now, PyGenX also gives an explanation for this code correction by saying, here is a comparison between the first generated code and the fixed one. The difference between the original code and the fixed one lies in the column name used to calculate the total fare. In the original code, the column name used is capitalized fares, while in the fixed code, the column name used is fare. It continues by saying, the error in the original code is likely due to the fact that there's no column named capitalized fares in the Titanic dataset. Python is case sensitive, so fares and fare would be considered 2 different columns. It also says that the number of code fixes attempted k equals 1, which means that PyGenX fixed the code in the first trial. As you saw in the code examples, PyGenX saves a lot of developer time by transforming LLM prompts into functional Python objects. Now, returning to our earlier question, why do we need to use PyGenX when other tools exist? Well, the straight answer is data security and privacy. Now, this imposes a risk if your data is really sensitive. On the contrary, PyGenX utilizes a data-agnostic approach, which means that it deals around the characteristics of dataset, not the data point itself. This means that your dataset will always be protected when doing any kind of data manipulation on it. If you are curious how I built PyGenX on top of LangChain, I created an online course at scimodel.dev. By the end of this course, I promise you that you will increase your coding productivity while preserving your data security. Thanks for watching and catch you soon. Peace.